All right, so hi everyone. My name is Mickey, and I'm working for a company you may have heard of. We do hotel room reservations, and just in case you were wondering, we're still growing, and if you are interested, then you can catch me later. I'm here to talk about something really cool we did at work. So, about a year ago, I joined Stephen Little's team, and we were asked to do something very simple. We were asked to cut the channel of communication to one specific database and put a web service in front of it. So we have better control on the application level for authorization and logging. And that sounded pretty simple. It sounded like a REST API. We all do REST APIs. We are familiar with them. We do them a lot. Now, just in case you're not familiar with them, let me just give you a quick review. A REST API is a way to represent data elements, no matter what they are on the server side. They can be in Elasticsearch, they can be in a database, can be a guide typing behind the server. They're all valid as long as we can represent them in a single way that the client can understand. Normally, this will be a JSON. It can be something else as well. Now, quick example. When we want to pull a data element from the server, we send a request. We tell the server we want to fetch, and we point to some resource and I will use the term resource to mean a uniquely identified data element. And we tell it, this is the type, this is the ID, together, this is a unique identifier. I want this resource. And the server will respond with a JSON that contains the data. It can also respond with another JSON that contains the data, or some other form of the data. Now here we realized that there is some problem that we have, and this is where this whole project spinned off into something a bit different, which is what I'm going to talk about today. The problem is, how do we know what is the format of this JSON? How do clients and servers know how to read each other's input? And sure, you can use some tools like JSON schema and some others and format them, but it still means that you will have to pair every client and server and generate code specific for this connection. If you have multiple servers that one client needs to speak to, it will have to implement all possibilities, and same for the other side. And this is something that we're not really happy about. And every time we have a project as a client-side developer or a server-side developer, you always have to go through this process of working with the other side to decide on the schema itself. Now, we found that we spend a lot of time doing that. And we also found that we spend a lot of time doing the same thing over and over. Even if we build a library to solve this problem for us, it will never work with a third party, or we will find cases where we also have to do it again. What we want is to focus on what we do, the logic that we need to do with the data. We don't want to care about how we transfer the data between the two sides. I mean, we never care about how IP works or how HTTP works, right? We trust them. We know those layers are solid. They will know how to transfer the data. We want something like that in this case, which means we need a protocol. So we looked it up. We found one interesting protocol. It's called JSON API. After reading the spec, we found that this is more of a complete solution to our problem, because it not only specifies how the JSON should look like, it also specifies the entire communication channel on a REST API. So it defines how you should request a resource and what the statuses and headers that should be passed around along with the data. So a complete solution. At the time, when we looked at it, there were many different implementations in all sorts of languages and PHP, and we had, but there was no a Perl implementation, and this is what we set out to do. Let me give you a quick example of how JSON API works. So just like the previous example, here we ask for a specific one uniquely identified item. All we had to do is tell the server we want a JSON API response through the accept header. If we used a body, if we actually passed a JSON, either way, we will have to also set the content type to the same value, but that's just to mean that there is a content. Server will respond with some JSON. You don't have to read it. Let me walk you through what we have there, the parts that are interesting. So there are some links. Links are optional, but they will point to the document. The document, by the way, is always an object, so we always know that we read it as a hash on a Perl level. So we have links that identify this document, how we got there. It can be self, can be relative links, all sorts of different links. We have also an optional parameter is the spec version, which is very important. Now they're releasing more versions of the spec, and we need to know on one side, on the client side in this case, how to interpret the response from the server. And the data. Now, the data in our case is one object because we asked for one. We uniquely identified one data element. If we asked for multiple ones, we would get an array of objects. Each one would have its own links. Again, they can be different if we have multiple ones. It will have the unique identifier, of this element. So in our case, let's say this element comes from a table. The type would be the table name, and the ID would be the primary key. So here we identified the element on the server side. The attributes, you can see them as the actual data, basically the rest of the columns in that table. Everything that we need to know about this element. This is where the actual data is. There is another section, very interesting one. It's called the relationships. This is how the server tells us about all the other data elements in other tables that relate to this data element. So you can think of it as a foreign key or a side table that maps elements between two different types. And it tells us about the connection. So it will give us the name. Name is what we keep as, just like with attributes. We have the name of the relationship itself, but inside we have the identifier of how we can get the data from the other table, and it can have its own links as well. A quick example, again, this time we have some parameters that I wanted to show. There are several ones defined in the spec. I wanted to focus on two interesting ones. One is the fields, and the other one is the include, sorry. And note the square bracket notation for the fields. We use it in JSON API. Now we got the different JSON. In this case, we asked for fields filtering. So just like with the normal query would be something along the lines of select star, this is like select and specifying the columns that we want to get back. So we said title and body. These are two attributes. So the attribute section shrunk to just those two. And we also specified authors. The authors is the name of the relationship, and relationships are considered the top level, just like the attributes. So if we want to see them, once we use the filtering of the fields, we also have to specify the ones that we actually want to see. Otherwise, we just won't have the relationship section. So this is why author is also there. The include is another one. Include is just like when doing joins, it's a pseudo join, but in this case, we also get not only the relationship to the other element, we get the entire element itself in an included section. So outside of our data, we will get, in this request, we got two data elements, not one. And we could have received multiple ones because we can have multiple authors, or if we ask for including of, let's say, comments or any other data type, we would get a list of a lot of different, we can pull a lot of different elements in one request, which is really neat. And we can go on and on about JSON API. It's a big spec, and I highly recommend looking into it. but this talk is about an implementation that we did for it in Perl. It's called PONAPI. I'll explain the name if we have some time after the end of it. This is an open source project that we did at work, at Booking, and unlike open sourcing a complete solution, this one was open source from day one. It started on my personal GitHub, and we just coded there. So this was really cool, because throughout the project you could have seen, if you followed it, you could have seen exactly how I spend my days at work. I hope you didn't, but it was pretty cool to do it this way, and the fact that Booking allowed us to do it this way. So it's on GitHub. Issues, pull requests, everything you want, go there. It's also on cPan. We released 3 different distributions. We have a distribution for a client, a distribution for a server, and another distribution that was just released last week, which is a tool set for building documents, which we separated out of the server because we figured that some people may want to use it to build JSON API compliant services in their own servers, but without changing the server, because our server is its own thing. Then they can use just the tool set to do that. And now it's also officially on the list on the JSON API website as the Perl implementation. Currently, it's the only one. Maybe there will be more, but PONAPI will always be the first and the best. Now, a few words about the server. It's the main project in this case. Thank you. It's the main one. It's the bigger project that took us most of the time. It is a Plaque component. You can basically install it and then just mount it, run it. It will work if you do one more step in between, and that is configuring the way that PONAPI server will communicate with your data repository, because otherwise it will not know how to serve your data. So you have to do that. And to do that, we added another tool, which is to help you create a PONAPI server project environment in a simple way. It's a command line utility built with app command. It's PONAPI with lowercase. Once you install the server, you will have it in your execution path. It has 3 major scripts in it. The manual will just fire up a Perl doc on the manual, which is a very long, extensive, very good description of how to use PONAPI. It was compiled by Brian Fraser and did tremendous work on it. And the other one is a demo, which you can fire up immediately after installing server. This is something fun, you can try it. It will generate a SQLite database, feed it with some data, and will fire up the server, connect into it, so it will be able to serve requests for it immediately. There is another flag that will randomly generate a query for you and fire it over HTTP to the server, get the response back, and tell you what the request was, what the result was, and also the JSON itself. There is another flag there that you can use if you only want the JSON because you're feeding it through some JSON reading tool, so you can suppress the first few lines. And this is really fun. Try it out. Every time you fire it, it will generate another query for you, but you can also do queries yourself with curl. Just remember to add the header for the accept, so the server will be able to serve you. The main one, the main script there is the gen. It's scaffolding of a project directory. So the directory flag is mandatory, of course. And it will create for you a directory which contains 2 important things. One is the PSGI script, so you can use it to run the server. It comes out of the box with an additional middleware that it wraps it with, which is the HTTP method override, because JSON API spec is using patch for updates, and not every client knows how to deal with that, so we have the method override to support that. The other one is the config, which is a YAML file. It's very short. Some tweaks that you can do to the server, not all of them required, like out of the box it will work. The only one that needs to be updated there properly is the repository handler, and for that you can either point to an existing module that you have and it will just check for you whether it can actually upload it and load it, sorry, and it will complain if not. Another option is for you to say new repo, and then it will create, it basically will create the whole directory structure under lib inside that project. And this is also a skeleton of the module. You can use it to build your own repository. What this handler needs to do is to implement several methods that we will, once we create an object of your repository-facing module, we will need to be able to call those methods in order to pull your data. Not all of them are mandatory. Some of them can be, if you don't want to support relationships, for example, you can just set all of them to an empty sub and it will work the same. Just because we cannot list, so we won't get to the other ones. The other ones, the rest of them are just basic CRUD operations. So you normally would already have them. You have a database or something that you want to expose with JSON API, you will have some sort of an ORM. So it's just mapping of a few methods. And you can do it very easily. I think Brian did it for class DBI in like 10 minutes or so. It was that simple. That's pretty much it for the server. You can look into it and ask me questions if you need about it later. Client is a smaller project, but it's nice to have. It's basically a Perl module that you can use to create an object which you can query the server through just calling the methods with the parameters that you want. It will send the HTTP request. It will set the headers and do the serialization and deserialization of the JSON for you, and you will basically get a response back which is already a deserialized JSON in a Perl structure. More features we're working on. We want to add some other things that we think that are good, and we also need them for work. The major one is something that the current spec of JSON API is currently being worked on, and that's extensions. We are mostly interested in the bulk extension because we want to be able to do bulk changes. So once that will be up on the spec, we will be able to push our changes to support it. It's not a big change for us, but we still need to be compliant with the spec. We make sure that PONAPI is 100% JSON API compliant, so we don't want to push it before that is up there on the spec. For more information about it, you can read the spec itself. It's jasonapi.org. Go to our GitHub repo or look it up on Metacpan. With that, I'm done. If we have like 4 minutes for any questions that you may have. Yes?
Yeah, so the repo,
the repo, yes.
Yeah. Can you talk a little bit more about how that might work with like a DBX class?
Sure. Basically, all you need is just to wrap the methods in a way that your ORM will understand. So I need to be able to pass information and say, I want to read this unique identifier. You can transform this to whatever you want. Those methods can be very, very small. They don't need to be more than a call to your ORM in the right order of parameters or whatever way you're passing them. But you can basically build a wrapper for any type of ORM. It can be Elasticsearch. It can be static data in static files. If you want to, if your module is just reading from Excel and serving it, that's fine. I mean, that's up to you how you implement it on the server side.
So it's more of a wrapper than a one-to-one.
It's just a wrapper, but it's a wrapper that we know how to communicate with. This is why we require those methods. One of when we ask for the configuration of your repository handler, we ask for two things: the name of the module.
Visible access modules have been overwhelmed a bit, so there is a preference. You can say, look, I don't do access, I don't do it. Let them know, and they'll make sure you don't get those modules. Okay.
Does that answer your question? So basically, we just need to have.
Tell them real quick. So,
That's great. Well, I'll talk louder. So another kind of cool tool we
Even
use
louder.
in class
So just to complete my answer to you is that we need to be able to create an object of your module. So we need the name of the module. And we also require you to provide, if you want, it's an empty by default, a list of arguments that we will pass to that when we call new on it. So the object that we get is something that we know that we can trust to work with that schema of methods. But other than that, you don't really need to know about the JSON API spec on how it works. You just need to provide us with that map to your data, and we will be able to pull it for you, and then you have a fully working JSON API compliant server. Any other questions? Right? Thank you very much for your time.